Okay, looking at a couple more from 14.3, remember all of these examples have a slight little twist to them, but this one's actually C, and this one is D. Okay. So first of all, we're going to do the discriminant, b squared minus 4ac. So remember that our a value is a is equal to 1, negative 1, and b is equal to negative 4, and c is equal to negative 4. Now, there's a little trick on this one that you could, if you don't want to work with all these negatives here, what you could think about is if we moved all these terms over to the right side of the equation, we would have 0 on this side, and all those would turn into positive signs. Or another way you could think about this is if we just change all the signs of all our A, B, and C values, that's perfectly okay because of that idea of manipulating the equation around. So I'm going to actually use A is equal to 1, B is equal to 4, and C is equal to 4. So I don't have to mess with so many negative signs. Okay. So let's substitute the values in here. We have 16 minus 4 times 1 times 4. I got that 16 from the 4 squared, our b value squared. So I have 16 minus 16, I have 0. Okay. So what that tells us is we're going to have one real solution. So working with the quadratic formula now, negative b plus or minus square root of b squared minus 4ac. If you write it down every time, you're not going to forget it. I get y is equal to, so remember I'm using 4 for my b value, so I have negative 4 plus or minus the square root of 0. Remember we already calculated the discriminant, and then over 2 times 1. So I have negative 4 over 2, and I get 2. So I get y is equal to 2. One real solution. Okay. I just want to show you this. If you would have recognized back at the beginning of the problem, and you might have missed this because we're working on the section of the quadratic formula, but if you would factor a negative out of this, we have y squared plus 4y plus 4 equals 0. And then this is actually factorable. So we get y plus 2, and oops, I have an error here. Lucky I did this. It should be negative 2, okay? And then y plus 2 equals 0. Then from the zero product property, we get y equals negative 2, y equals negative 2. And we don't have to list the repeating root. Okay, so we see we get the same answer that we got using the quadratic formula. Okay, by factoring. But since we're in the section of quadratic formula, we probably should use that. So the thing that this problem is trying to teach you is one thing for sure is that you should get this in standard form to find your A, B, and C value. So I'm going to add 3x here and add 3x here to get this into standard form so I can have my A, B, and C value. So I have x squared plus 3x plus 3 equals 0. So my A value here is A equals 1, B equals 3, C equals 3. I'm going to calculate the discriminant, b squared minus 4ac. So I have 3 squared minus 4 times 3, substituting in our values. I have 9 minus 12, negative 3. So I have 2 non-real solutions. I know an imaginary number is going to come out in this quadratic equation here. So I have negative b plus or minus the square root of b squared 2a. I have x equals, let's see, my b value is 3, so I have negative 3 plus or minus the discriminant is negative 3 all over 2 times 1. Remember that needs to stretch the entire length here of the numerator. And so I get x is equal to negative 3 plus or minus radical 3I over 2. And do remember there's 2 solutions there. You could break it up into 2 solutions. It'd be negative 3 plus the square root of 3I over 2 and negative 3 minus the square root of 3I over 2 if you needed to type in both of the solutions. So 2 non-real solutions. Okay. A real challenge is to take this value and put it back in the original equation and show that it's equal. Okay. If you're going on to college algebra or pre-calc, you might do that in those classes, or you could even do it as a challenge now.